Hi, today we're looking at section 8.4, which is equations of sinusoidal functions. So in the previous section, we looked at being able to calculate our amplitude, our period, our midline, and essentially in today's notes, we're going to look at how that affects our graphs of y equals sine x and y equals cos x. So any sinusoidal function can be modeled with a function y equals a sine of b x minus c plus d, or y is equal to a cos of b x minus c plus d, where a is our amplitude, b stretches or compresses our graph horizontally, so it controls our period, c shifts our graph left or right, d shifts our graph up or down. It is also the y value of our midline. So we'll look at how to exactly calculate our A, B, C, and D. So A is our maximum y value minus our minimum y value divided by 2. B is 2 pi divided by our period if we're doing with it in radians. If we're doing with our function in degrees, it's 360 degrees divided by our period. Our midline we can get by looking at our graph, which is our D value, or we can take our maximum y value plus our minimum y value and averaging those, so dividing by 2. To get C is equal to the distance from a vertical axis to a first midline point where our function is increasing for sine. For cos, we're looking at the distance from a vertical axis to a first maximum point. All right, so we're going to look at this example for y equals 3 sine of 2x minus 3 from 0 to 2 pi. We want to describe our amplitude, the midline, the range, the period, the horizontal translation, and graph using technology to confirm. So first thing is we're looking at a graph of sine. So that takes a form of y is equal to a sine of b x minus c plus d. So if you remember, our a value here is our amplitude. So our amplitude is this value here. So our amplitude is going to be 3. Our midline is our d value. So in this case, our d value is -3. So our midline is y is equal to -3. Now our range, we can use our midline and amplitude to figure out. So our minimum point is going to be 3 units, which is our amplitude, less than our midline. So -3 minus 3 will be -6. Our lowest point should be -6. And that's equal or less than y, which is equal or less than our highest point. So our highest point would be -3 plus our amplitude. So that would be 0. Now, B controls our horizontal stretching or compressing. So B is 2 pi divided by our period. Now, in this case, 2 is our B value. So we've got B is equal to 2 pi over our period. We have a B value of 2, so we've got 2 is equal to 2 pi over our period. We'll multiply both sides by the period to get out of our denominator. So 2 times our period is equal to 2 pi. Divide both sides by 2. Our period is going to be pi. So our period's pi. So what this means is our normal period's 2 pi. This one's period is half of that, which is pi. So our graph should be repeating twice as often. Now, in this case, horizontal translation would be our C value, but we don't have a C value. So our horizontal translation will be 0. Okay, so we're going to graph this to see if our guesses were correct. So this would be our graph. We can see essentially our midline would be about here. That is a y value of -3. 3 units above that, we have our maximum. 3 units below that, we have our minimum. Our range is going from -6 to 0. And we can see that essentially our distance between, say, 2 minimums or 2 maximums is going to be pi. So that's our period. And we can also see that we didn't horizontally shift because our graph of sine is going through 0, 0.